So in this video, we're going to talk about the alternating series, and the general form is usually given by this negative one here. This is a characteristic of alternating series. This is negative 1 here raised to the n plus 1, and this 1 over n could represent anything. I just use the simplest form of 1 over n, which I could also rewrite as u sub n. Okay, and this is the part of the series that we actually do care about. Now, in order for these series to be convergent, in order for the series to converge, there are two conditions that we need to meet. We need to meet the conditions that, and this, I'm sorry guys, but this is u sub n plus 1, so let me rewrite it. So this is u sub n plus 1. So the u sub n plus 1 has to be less than or equal to u sub n. Okay, we're going to talk about what that means. And then the other one is that the limit has to equal 0. Okay, the limit has to equal 0. Okay, now with these is that most of these alternating series is that usually it will take a while to converge, but it will we call it conditionally converges, right? It takes a while to converge, and then eventually it will converge. It's just like the exponential function e. You start off with a little bit, and then after a while it just starts rising exponentially. Okay, so that's the idea behind the alternating series. So let's look at what we mean by this idea of the u sub n plus 1 has to be less than or equal to u sub n in order for it to converge. Well, the idea is that if I take 1 over n plus 1, because all I'm doing is plugging in n plus 1 for n, and on the other side I have 1 over n. Okay? The idea is if I take some numbers, so let's say if I take 1 to plug in on both sides, if I plug in 1 into both, I get 1 over 1, which is 1. If I plug in 1 over here, I get 1 over 2. So notice that the u sub n is actually less than or always equal in this. Okay, and the idea is that if I plug in 2 here, well, I get 1/3. So let's plug in 2. I get 1/3, which is less than, if I plug in 2 here, I get 1/2. Okay, again, 1/3 is always less than a half. So that's the idea behind the u sub n plus 1 is less than or equal to u sub n. So that has to happen, which means that the series is actually decreasing, and the limit has to be equal to 0. Okay, so those are the two things that we have to make. The limit as n approaches positive infinity of an has to be equal to 0. Okay, so let's look at a couple examples. So actually, let's look at this itself. Okay, where n is equal to 1, that goes to positive infinity of -1 raised to the n power of 1 over n. Okay, well, again, this is the part we care about. Okay, it would just prove that the u sub n's are actually less than my un, which is the original part of the series. So we know that is true. And listen, if I take a limit as n approaches positive infinity, and again, we only care about this part of the series. If I take a limit as n approaches positive infinity of 1 over n, and notice that this is equal to 0. So the two conditions we meet, and so actually we could say that the series from n is equal to 1 to positive infinity of -1 raised to the n power of 1 over n times 1 over n, this actually converges. And it converges conditionally. Okay, but it do converge. Okay, now let's look at another one. What about this one? From k is equal to 1 to positive infinity of -1 raised to the k plus 1 times k plus 1 over 3k plus 1. Okay, does this series converge or diverge? Well, we see this -1 here, and this is a characteristic of alternating series. Okay, and so the idea is, okay, well, which part we care about? We care about this part. And there's two conditions that we need to meet. Okay, now this condition is harder to, it's not harder, it just takes a little bit more time. And actually, you could just plug in one number and actually it'll work. But again, for me, it takes time. And so the idea is, the first thing I'm going to do is going to do a limit test. I'm going to do a limit test. And so if I take the limit as k approaches positive infinity of k plus 1 over 3k plus 1. Well, again, our nifty little trick, we take the ratio of the coefficients because the highest bars are the same. And so the limit is actually 1/3. Well, the limit does not equal 0. And so we know that this actually diverges. Okay, so again, that's the idea behind the limit, not limit, the alternating series, okay? So usually given in this form, okay, and we gotta meet two criteria. We already spoke about them, and the limit is the easier one to tell. The limit, if the limit has to be equal to 0. If it does not, then we know this cannot converge. Okay, and so that's the general idea. Now there's one more thing I want to talk about to be careful of. We already talked about the idea of alternating series being in this pattern, but in fact, if I look at this series, here from n is equal to 1 of -1 raised to 2n times 1 over n. Well, in fact, this series is not an alternating series, okay? So if I plug in 1 in for n, well, 2 times 1 is 1. If I square negative, I get 1. And this is 1, okay? So I get a 1 here, and 1 over 1 is just 1. So the first term is 1. If I plug in 2, well, 2 is 4, okay? If I raise -1 to the fourth power, I get a positive 1. Okay, and this becomes 1/2. So this is 1 over 2. So my second term is 1/2. So notice that this is not alternating at all. Okay, and so so majority of the time it's easy to assume that given in this form we have alternating series. But again, most of the times your teacher probably won't do that to you, and this is kind of a trick. Okay, honestly, but your teacher probably won't do that to you. But I was just saying, be careful. But most of the times in this type of form, it's usually an alternating series.